Hello, pre-algebra fiends. Welcome to another episode of Mr. Chao Time. Here we are dealing with direct variations, lesson 4, page 405. So, what is a direct variation? Well, it's just a special kind of relationship. So, we've been looking at relationships where there is an equation that can represent it, such as y equals 2x plus 1. And this relationship can be graphed with a line, right? Well, with a direct variation, which is also sometimes called a proportional relationship, this is how most of your textbooks growing up will call it, but not the one that we use for some reason. In this type of relationship, the ratio between the rate of change will always be the same. And one way that you can know that that's happening is that if the line passes through the origin, the middle of the graph, where the x and y meet. And that's really, that's basically what you need to know. That relationship between the x and the y, that's called the constant of variation, or sometimes the constant of proportionality. So let's take a look at an example of that, because it will help make it make more sense. So for example, let's say that we have this relationship between the weight of Snickers and the cost of Snickers. So is this a direct variation? Well, we can write some of these points. For example, if we have x and y, where x is 0, y is 0, right? Which is right here. And where x is 4, y is 14. And then 8 and 28. And then 12 and 42. So we're not going to look at this 0, 0. Although this is one of the ways that you can tell if a relationship is a direct variation. We're going to look at these others. So what is the change here? What is the relationship between cost and weight? Well, the relationship between cost and weight is 14 over 4, right? Y over x. And then we look at 28 over 8. And then we look at 42 over 12. And look, all of these are equivalent fractions, right? And because we know that, because these are all the same value, so for example here, 7, 2 is another, then that is what makes this a direct variation. So yes, this is a direct variation, because if you write the different points along the graph, they all equal each other, with the exception of the 0, 0, because it passes through 0, 0. Okay. So your turn. Let's say that Daniel charges his customers $100 per week, plus $50 every time he walks their dogs, because he's a dog walker. So he's going to walk people's dogs. If you hire him, it costs you $100, plus every time you want him to walk your dog, it'll be $50. So is this relationship a constant variation or a direct variation? These are all different ways of saying the same thing. So, for example, if I ask him to walk my dog 2 times in a week, 2 times, then that's going to be $200, right? Because it's $100 plus $50 every time that it's walked. The dog is walked, and that's y. So if I put 2 into x, that's 100, or 2 times 50 is 100. So let me just write that on here actually, just so that everyone is clear on what's happening. Now this is 200, right? And let's put in 4. So 50 times 4 is 200, plus 100 is 300. So is 300 over 4 equal to 200 over 2? Well, one way that we can check is with the butterfly method. Remember this? Where you multiply these numbers and you multiply these numbers and see if they're equal to each other. Well, 200 times 3, or 2 times 300 is 600, and 4 times 200 is 800, and they're not equal to each other. So this is not a constant variation. Okay? Okay. Here's another example. Let's say that the equation y equals 40x represents the distance y in kilometers Tiffany can travel in x hours. So determine whether there is a constant of variation. If so, explain what it represents in the situation. So again, we will put in some different numbers for x and y. So let's just put in 1, 2, and 3. So where x equals 1, it's 40 times 1, which is 40. Where x equals 2, it's 40 times 2, which is 80. And 40 times 3 is 120. So are these equal to each other? 40 over 1, 80 over 2, 120 over 3? Yes, they are. 40 times 2 is 80. 80 times 1 is also 80. 80 times 3 is 240. 120 times 2 is also 240. So yeah, these numbers are all equal to each other. And you could even multiply 40 and 3 and 120 and 1, and you would still get the same thing. So this is a constant of variation. So what does the constant of variation mean? Constant of variation is 40, right? Or 40 over 1, or 80 over 2. So this is 40. 40 means that she's traveling at 40 kilometers per hour. That's the speed. So she's traveling 40 kilometers per hour. X is the number of hours, and y gives you the total distance. So 40 is the speed that she's traveling. So that's what it means to explain what the constant of variation represents, which you will be asked to do. Okay, your turn. The equation K equals C plus 273 is the relationship between degrees Kelvin and degrees Celsius. Determine if this is a constant of variation. Okay, welcome back. So if we put some numbers into C, so let's say 1, 2, and 3, because those are easy, then we get 1 plus 273, 2 plus 273, and 3 plus 273. And that equals 274, 275, and 276. And as you can see, these do not equal each other. 274 over 1 does not equal 275, that's a 7, over 2. And so, yeah, not a constant of variation, so we don't have to explain what it means. So the time it takes Chloe to upload her Genshin Impact stream varies directly with the length of the video. So they're telling you now that this varies directly. And you can see here, it starts at 0, 0, and it's a straight line, so it varies directly. write and solve an equation to find how long it will take to upload a 700 megabyte file. So remember, a constant of variation means that we're always multiplying x by the same number to get y. That's basically what we're saying when we're saying that the relationship is constant, right? It's always you multiply x by the same thing to get y. So if x here is 2.5, we can make a little table here. If x is 2.5 and y is 10, what do we have to multiply 2.5 by to get to 10? Well, that's 4. How about 10 and 40? Yep, times 4. 25, 100. Yep, oops, 4. So it's 4 times x. So this is how you would see the relationship. Each one of these is times 4. And this is the way that direct variation or proportional relationships are going to look. It's always going to be x times something equals y. It's never going to have an add. For example, if we look back at, was it this example? Yeah, this example here. This was 100 plus 50x equals y. And you see this, it has this add here. So it cannot be a constant of variation. Back to here. Nope. Back to here. So this is our equation. Write and solve an equation to find how long it will take to upload a 700 megabyte file. So megabytes goes here, and we're solving for time, right? So we want to know what if we multiply 4 by 700 is. And that's 2,800 seconds. All right. Okay. Your turn. The cost of Marvin's homemade lemonade varies directly with the volume of the drink. Volume, remember, is a measurement of how much liquid. So 2 liters costs $580. So the amount of what is this, lemonade? So liters versus total cost. Total cost is going to be y. That it depends on the liters, so that's the x. So 2 liters costs $580. How do we solve for that if we only have one relationship? Well, it's just going to be the y, the dependent variable, over the x, the independent variable. And then we're just going to simplify this. So that's, what is that? 250 plus 40, 290? 290 is the constant of variation. So our equation is just going to be the constant of variation times x. 290x equals y. Then we're going to use this to solve for 5 liters. So 290 times 5 equals... Sorry, I got distracted there. I thought someone came into the room. 45, 10, 14. So $1,450. Marvin's rolling in the dough. All right. One more example. The equation y equals 1.5x represents the relationship between the number of heartbeats y, number of heartbeats y, and time in seconds x for a student in love. The graph shows the heartbeats of a student arguing. Which student has a faster heart rate? So now we have an equation and a graph, and we're going to compare the constant of variation between the two. So here, you take the time in seconds and we multiply it by 1.5, and it tells you how fast the heart is beating of someone in love. Here, so we already know the constant of variation here is 1.5, right? Here, we have a student arguing, and we have this different number of heartbeats, right? So for every 1 second, it's beating 2 times. So that would be 2 over 1. So which one is beating faster, 2 or 1.5? It's 2. The students arguing have a faster heart rate, and we know that because the constant of variation is higher. Your turn. Let's say that the equation y equals 3x represents the heart rate of a student after a terrible breakup, where x is the time in seconds, again, and y is the number of heartbeats. Does the student with a broken heart or a student arguing have a faster heart rate? Welcome back. This is the same relationship. This is the same graph that we just saw. So it's 2 over 1, right? Which is 2x equals y. This is our equation. We have y equals 3x. So you can see here that 3 is bigger than 2. So 3 being the constant of variation, being higher, that tells you that the heart rate is faster. So which one has a faster heart rate? It's the student with a broken heart. Okay. Here's your must do. Enjoy.